Okay, we're going to start 5.2 notes about the unit circle. Really one of the most important sections here as far as trigonometry goes. It really lays the foundation for what we're going to do. One of the big ideas here is the unit circle itself. The unit circle is centered at the origin, or 0, 0, and has a radius of 1. Okay, the equation for the unit circle is then just simply x squared plus y squared equals 1, just based off the equation for a circle. Okay, now what we're going to do is we're going to take the stuff that you did in 5.1 and use the unit circle to kind of start expanding our understanding of unit circle and trigonometry itself. Okay, we want to find points on the unit circle. Now, find a point on the unit circle that is in quadrant 3. Okay, so this is quadrant 3 down here. That has a y-coordinate of -3/4. Well, to do that, we're going to use the equation of a circle. We're going to plug in the coordinate that we know here, -3/4 squared equals 1. If we begin to solve, and we want to solve for x, so we end up with plus 9 over 16 equals 1. X squared then equals 1 minus 9 over 16. Okay, or x squared equals 16 over 16. That's the 1. Get a common denominator. Okay, or x squared equals 7 over 16. And if we take the square root of that, both sides, okay, we end up with x equals plus or minus the square root of 7 over 4. Now, what we need to understand here is, in this case we have two coordinates for x. Here, somewhere over here, is negative square root of 7 over 4. And somewhere over here is the positive square root of 7 over 4. We are looking for this one because that's the only one that would give us a point in quadrant 3, okay, that would have a y value of -3/4. Okay, so our final answer is the point negative square root of 7 over 4 -3/4. Okay, now to find other points on the unit circle, one of the things that we'll want to make the connection for, and here's the main reason, these are special points or easy points that you can find without the use of a calculator. So what we're going to do here is take a look at our special right triangles that you looked at in the last section. Okay, and this could be a 30-degree angle, or we would say pi over 6 radians. This is a 60-degree angle, which could be thought of as pi over 3 radians. Okay, and here's our 90-degree angle. You went over the relationships of the sides there. Now, to convert that to the unit circle, what we just have to realize is the radius is going to be 1. And we're always going to make the hypotenuse the radius. So here we have our pi over 6, and here's our pi over 3. Okay. Now, if you look what we did to get there, and because these triangles are similar, all we did was divide by 2. So we can divide each side by 2, and that will give us the side lengths of our special right triangle on the unit circle. This is a very, very important concept that comes up a number of times. In our other triangle, which was a 45, 45, 90 triangle, or a pi over 4, pi over 4, pi over 2 triangle, okay, we again are going to make the hypotenuse equal to 1, and really if you look, how we did that was we just divide everything by the square root of 2. So each side here is 1 over the square root of 2 and 1 over the square root of 2, and if we rationalize those, that's the square root of 2 over 2 and the square root of 2 over 2. Now we use these special right triangles here to help us find points, and they're relatively easy to find. So let's take a look at this. Using a 30, 60, 90 special right triangle to find the point on the unit circle that shares a point on the terminal side of the angle of pi over 3 radians. Okay, well, first let's make sure we understand pi over 3 radians is here, okay, and this is also known as 60 degrees. Okay, now if that's 60 degrees and this is our point and our radius is 1, what we're really talking about here, and I'm going to blow this triangle up, okay, what we're really talking about here is a special right triangle, because if this is pi over 3 or 60 degrees, then this one has to be pi over 6 or 30 degrees. And so what we have here is our special right triangle with the side opposite the pi over 6 being 1/2, and the side opposite the pi over 3 being square root of 3 over 2. And if we see that, and we notice here that the point that we're looking for in green, okay, is has an x coordinate of 1/2 and a y coordinate of the square root of 3. Really important that you understand this example. So our special point in this case, by what I described there, is an x coordinate of 1/2 and a y coordinate of the square root of 3 over 2. That comes from the special right triangle that we formed on the unit circle. And that's it.